Cord to the cloud. Okay. Well, good evening, everyone. Here we are on the 28th of April, and we have Dr. Inara Watson, who's going to give her presentation into the investigations into the decarbonization of railways. And so it's actually quite a interesting topic, a very relevant topic of the time. Let me just give you a brief bio on her. She's a lecturer at London South Bank University, and she was born in Latvia and graduated with a Bachelor's of Science in Mechanical Engineering from Riga Technical University. She has a PhD from London South Bank University, and her research interests are focused mainly on railway engineering and sustainability. In 2018, she presented her research at the UIC Congress on high-speed railways in Ankara, Turkey. In November 2019, she presented her research at the UIC 7th Next Station Conference 2019 in Tehran, Iran. Inara has several publications in various journals and presented papers at conferences throughout Europe and Asia. And for the last 3 years, she's been writing for the PWI journal, and she's a member of PWI, ICE, and the OR DMDU societies. So with that said, I'll hand it over to Dr. Inara Watson. Take it away.
Thank you. I will hope, keep fingers crossed, everything will go well today. So, it's me. And as you see, my motto is always forward. Does not matter what happens, always. Yes, as Mike said, I have my BSc from Riga's Technical University. And after my BSc, I worked for a number of years in Latvia on Rezekne 2 railway station. And I have my MSc and PhD on sustainability and related factors of high-speed railway from London South Bank University. I went to China for some time to teach students. It was an exchange from my university. And it was quite memorable trip. And also I went, yes, to Iran in 2019. So I authored 2 books. First, my book was Investigation of the Silk Road Economic Belt Initiative, published a couple of years ago. And my second book is Investigation into the Decarbonization of Railways. And we will talk today about this topic. So, to better understand and to look wider, we needed to take a system thinking approach about decarbonization, because many different factors can affect how we can do with this topic. And some of these factors, I choose a few of them, in my opinion, the most important, we will touch today, but more, I talk about more about these factors, I talk in my book. So, these presentations will contain overview and we look advantages of electrified railways and international summary. Then I talk briefly about factors affecting the energy consumption by high-speed railway. Then we look life cycle assessment and manufacturers of rolling stock, resource efficiency, and new technologies to reach zero emissions. And last will be UK plans to accelerate the decarbonization of transport. So, with increasing population and globalization increase demand for transport. It was estimated that by 2050, we needed to build over 25 million of kilometers of road and around 334 kilometers of railway track to satisfy demand for travel. As you understand, with this increase in demand of travel, increases emissions that produced by transport industry. from 19th century, when was around 2 billion tons of CO2 produced annually, it's increased to 36 billion tons by after 115 years. And in 1971, transport responsible only for 19.3% of CO2 emission. By 2019, it's increased for 24% of total CO2 emission. The environment impact of railways, it's lower than any other transportation mode. Railways, in UK, the transport sector was responsible for 33.6% of CO2 emission in 2018, but railways only around 1.4%. They transported over 10% of passenger kilometers and over 9% of total freight ton kilometers. To keep global temperature under 2 degrees, we need to do something to decarbonize of transport, and railways must do the bit in the decarbonization of transport industry. The three main approach to achieve decarbonization on railways, and it is reduction of resistance to moving by reducing, example, the weight of rolling stock, improving aerodynamic drag, reducing of dependency of diesel technology, and switch to renewable energy resources. So, but this not so easy because it's not only need to switch to renewable energy resources, but to electrify railways, but need to look how we produce this electricity. And this slide shows electricity generated in UK by the sources. It's data taken pre-COVID, because when we have last 2 years COVID, it's affect all figures. And you can see in UK increase the percentage of renewable energy in 1 year near 4%, but decrease nuclear and gas generated electricity increases. We'll have this problem now with this gas, and decrease electricity generated from coal. In the right side of these slides, you can see on table 6 countries in Europe comparison how they produced electricity but it's back in 2005. And if you look example UK, you can see we substantially increased renewable energy in 15 years from 5% to near 37%. But you also can see we reduce amount of nuclear energy. And this, of course, will cause now some problems, because we will problem with this gas. If you look in example Germany, Germany have more difficulties, because they have lots of energy produced by solid fuels, coal, and they also reduce substantially nuclear energy from 26.7% in 2005 to 13.3% in last year. And they, after disaster in Fukushima, they decided to stop all the nuclear power plants by 2022. But I think now what going in Europe, it will be probably they will reverse this plan. So to decarbonize railways, not all depends on railways, depends on electricity mix produced in country. So now we can look the share by transport mode in greenhouse gas emissions by the energy demand in Europe in 2014. And you can see that railways are responsible only for 0.6% of total gas emission from transport. But anyway, it's still lots to do the better. And yeah, of course, road transport, it's the most polluted transport in our roads. So, and this slide shows the share of electrified and non-electrified railway lines in the selected country. I selected few countries, and you can see that UK, it's in back 2013, but it's not so much changed. And example, UK have electrified lines around 30%. But in other countries, if you look, example, Poland or Spain or Italy, they have much more electrified lines. So we need lots to do in UK. If you can see, UK has lowest percentage from these selected countries. So yes, but another things, how many locomotives is powered by diesel. And if you look these slides, you can see example Denmark or have over 70% of locomotives powered by diesel power. And if you look another corner of these slides, you can see that Sweden, Finland, Portugal, they're doing quite better than UK, than Denmark. And but if you look Latvia, because it's my country I choose, you can see they have all locomotives. What country has all is diesel locomotives, and most of 95% of all transport worldwide is powered by fossil fuel. But it was forecast that all reserves in the world will be run out within the next 50 years. And we not have any choice how look for different energy resources apart from fossil fuel. So, and the most important tools to reduce consumption by rolling stock are, I speak here about rolling stock because of around 85% of all pollution what created by railway. It's created in operational stage. And this we need to look at what rolling stock we use and how we use, and maybe needed to improve technology. We can reduce energy consumption by rolling stock by improving aerodynamic of train body, reducing train mass, applying regenerative braking, increase the capacity of train, adapting new operational and behavior approaches, eco driving, and improve energy efficiency of no traction equipment, funds, lightning, and so on. So, and then I look, I choose 7 high-speed railways, and I look how they efficient and using the energy. What type of rolling stock they have. It was these 7 countries: France, Germany, Italy, Spain, Japan, Turkey, and South Korea. And you can see that most powerful powerful train sets has Japan and South Korea. And maximum energy consumption by high-speed railway, of course, depends on train speed also. And depends on axle load, I will show you later, and it depends on average capacity of train. And you can see that, example, Japan has near double capacity of train to what we have in Europe. So these slides show the ratio of passenger kilometers per seat. It's not, it's also depends how efficiently we use a rolling stock. We can buy and can, but do you use to full power? It shows how intensively we use our railway lines and rolling stock. And if you look at the passenger kilometers per seat, Japan has highest passenger kilometers per seat. Ratio mass per seat, also you can see Japan has lowest ratio mass per seat. Also, of course, it depends on age. I know in Turkey, these have quite new rolling stock, but it's because they opened their railway lines just, I think, in 2010. But if you look rest of the countries, example, Japan, which started to operate high-speed railway in 1964, France, Germany, Italy, Spain, you can see that Japan has most the average age of rolling stock in Japan less than in the countries in Europe. And this gives them advance because they can all time use more efficient rolling stock who you need less energy, and it make the railway transport more efficient. Also, of course, on energy consumption depends what type of rolling stock you have, how it's powered, it's distributed power or concentrated power, articulated, tilting trains, double decker. It's also, of course, effect of energy consumption. And we'll look later how it's can affect. So, this slide shows the comparison of the selected high-speed rolling stock in terms, what I said, of ratio of passenger kilometer and mass of train per seat. It's little bit different ways, but you can see Japan, it's a best performer in this way. So, if, yes, I speak about age, now you can see what rolling stock have selected countries. In Japan, they are more energy efficient, and they have actually also the rolling stock has distributed power supply. And they, half of them have tilting trains. And distributed power supply gives these benefits that its trains have less axle loads and have higher speed, and yes, and again, it's use less energy. No, of course, for Japan, what I can say more, they have wider railway carriages because they did not have any restaurant carriage because, yes, and because they have distributed power supply, it's not need locomotive. The number of seats on train higher than we have example in France. Yeah. about this. So, but operational, yes, of course, operational stage of rolling stock responsible for approximately 80% of all energy and all CO2 emissions that produced by rolling stock. But no, not need to forget the extraction, manufacturing, and end-of-life disposal stages. And if you look in Europe, in 2017, it was around 100,000 passenger vehicles and around 400,000 of freight wagons. But by 2000, by end of the century, the global solid waste generation early will be triple. And we now have these problems, what we can do with this waste. We not how we or we transport or find ours in a place and country where we have landfill. But with by end of the century, its problem will get more worse. And but because of this, one of the way to increase decarbonization of railways is to reduce the volume of raw materials used for railways. And if we go back to Japan, they have lightest rolling stock, something between 11 and I think 17 tons per axle, because they use less raw materials to build this rolling stock. End of the when it need to end of life disposal, of course it will be less to go to landfill, because needed to, it's about these slides, needed to think about reduction of raw materials what we use to build rolling stock on started on design stage. And when we design, need to think because the minimization of volume of natural resources used to manufacture rolling stock also will minimize the post-production waste, and will but also when we design the new rolling stock, we needed to think how we simplify the dismantling, because it will be easy to reuse and recycle most of the components. When recycling, it is it's not possible, then we needed to think how we can use to recover the energy. Yes, and what is left, it will go to landfill. I don't remember now percentage, but currently in landfill goes quite, I think something around 13% of end of the end of the life of rolling stock. So then we go to next slides, and I'm not missing anything. And here you can see 10 biggest manufacturers of rolling stock. And yes, two places belongs to China manufacturers. I did not have so much information about China. But what about, say, about Bombardier? I have this data that their vision is to achieve 100 product recyclability, and currently 95% of what rolling stock they manufactured, its recovery rate of all rolling stock what manufacture Bombardier is around 95%, and French AGV has 89% of recyclability. So yes, you cannot see in this table Japan manufactures, because Japan produces so high quality rolling stock, it difficult to use outside the Japan, because our infrastructure did not quite match level of quality infrastructure in Japan. So yes, now you can see that to reduce the weight of rolling stock, it's important how we manufacture, what materials we use to manufacture car body. And you can see that Japan mostly use carbon steel and aluminum alloy. And because the trains more light. If you look example USA, the USA Bombardier Axle Express, it's a lot 23 tons, and they use stainless steel. It can be explained by it's in safety reasons. They need more heavier locomotives because they did not have these fences along the full high-speed railway line, and because they have number of level crossings, what we not have in Europe or in Japan on high-speed railways, because in case they have some debris on railway line, they needed to protect locomotives, because the locomotives is more heavier. So, and in future is a number of researchers that work to introduce carbon fiber reinforced polymer for car bodies, but it's only research stage, because there will be another raised question about recycling. It's more easy to produce, but quite energy consuming to recycle these carbon fiber reinforced polymers. So, fiber. Not only efficiency, energy efficiency of railway lines depends on what technology we use, what rolling stock, but also depends on how we use these railway lines and locomotives, how we operated them. And sometimes country can build high-speed railway line, but it's not used to full capacity, or country have purchased a number of train sets, but it's again, it's not used to full capacity. And because not needed look not only on designer stage, manufacturing stage of rolling stock, or building infrastructure, operating and disposal, but need to look how we operated and need to look the best ways. One of them would be to introduce eco driving, what is now. Yeah, it's need to look maybe have improved the infrastructure to reduce the amount of energy used by rolling stock. So, and this slide shows high-speed train sets in use per 1 kilometer or high-speed railway line in 2020 in the selected countries. And you can see that 3 countries use the rolling stock more intensive. It's Japan, South Korea, and Germany, France. But rest of the countries, yes, it's not so intensive. It's of course it will not recover embedded CO2 emission in construction these high-speed railway lines. So, and these slides you can see the yes, we built railway infrastructure, but maybe to 100 years and longer. But if we not use to full capacity, it never will pay back. Example, the construction of 1 kilometer of railway infrastructure contribute around 1.4 tons of CO2 emission. The highest amount of embedded carbon is by construction of tunnels, bridges, viaducts. And regarding the high-speed 2, it will be embedded 5.6 million tons of CO2 emissions. But it will pay back or not, it is question. And if you look about rolling stock, what I said before, in Europe, it's around average life of rolling stock is 30 years, but in Japan, in 15 to 20 years. And they all, in Europe, we needed, in middle this, approximately in the middle, after 15 years, we need to have a major maintenance, renewal, but in Japan, she just built rolling stock, use, and introduce new, and because for them not needed this middle age when they will be have major maintenance. And it's sometimes this major maintenance can be in economically equal to purchase a new rolling stock. So, but in other hand, by using this rolling stock longer, it's we can save in raw materials, and can be some saving in another way. Okay, this slide shows the typical train materials contents, and you can see the highest percent, 76% belongs to metal. Metal quite easy recycle, and next highest percentage belongs to electric and electronic equipment, and this we have some problems to recycle, and I will show you later. One of the ways, but we needed to try to use, after we recycling, we needed to use more recycled materials in our building infrastructure and rolling stock. On this slide shows one of the examples in Australia when slippers manufactured from plastic and polystyrene, and I think we have some examples using this type of slippers in UK also. So, but this slide shows what I said before about waste electrical and electronic equipment in the selected countries, kilogram per capita. And you remember that rolling stock have approximately 11% of weight belongs to electronic and electrical equipment. If you look in UK from 2009 to 2018, actually weight of waste, what was collected is instead of increase, it's drop from 0.22 kilogram per capita to 0.12 kilogram per capita. But in some countries, it's of course look figures better. Example, Sweden increase what electrical electronic waste they collected and to recycle, and in Germany, in Spain, in France, and it's average figures by in Europe in 2028, in 2018. So then we needed to think how we build, then how we use, and now to decarbonize railways, we needed to think also how we will dismantle, reuse, and recycle our rolling stock and infrastructure, of course. This slide, but if we go back to reducing the CO2 emission from railway industry, the most powerful way to do this is to electrify railways, and some part of railway is it's not economically valuable to electrify. Need look to another way how you power trains, and here can be example from Japan shows electric motor driving hybrid rail car and charging accumulator rail car. It's to decarbonize operational stage of railway system. It's need to use batteries or hydrogen, but in a stage when we are not reach this fully decarbonization, one of the solution can be to use diesel electric powered trains. And on sections where it's electrified, it's used powered by electricity, but in some sections, example in tunnels or in bridges where difficult to electrify, it can be used diesel. But no, must to remember that in this stage, when used diesel, train cannot reach the speed what they can reach on electrified lines, and they of course produce CO2 emission. But this can be can think as a stage when we can use these trains before fully decarbonized railways. In Europe, around 20% of traffic and 40% of railway network is still served by diesel locomotives. But in some countries, 100%, as you remember. One of examples is Latvia. On less intensively used lines at the first and the last miles of travel, the battery and hydrogen train are likely to be delivered lower whole life cost than electrification. I cannot remember now figures, but approx in Europe, 1 kilometer or to electrified railway line cost over 2 million euro. Probably in UK, it will be more expensive. So on these slides, you can see the East Japan Railway hydrogen powered vehicle, and future of railway, it will be electrification. If we not can, if it's on section we cannot electrify, it will be powered by batteries or by hydrogen. And here you can see that battery powered trains have a range of operation up to 100 kilometers. Of course, speed up to 125 kilometers per hour, and with extra weight between 3 and 10 ton for battery. It will be depends what speed you want to reach. If it's higher speed, it will be more powerful battery, more will be more heavy. By 20, but this also, it's not matter where we go, we have the problem. This also will raise the problem because this moment battery is more easy and more cheaper to produce new than recycle the used. And by 2050, it will be necessary to dispose of approximately 22 million tons of batteries. Also, if we go to produce batteries, we use some rare materials, rare metals, example, lithium. And to extract 1 ton of lithium, you needed to use approximately 100,000 liters of water. And not so many countries, around 10 countries in the world, around the world, have these rare minerals that needed to produce batteries. And if this moment, we depends on, example, on Middle East or Russia on fossil fuel, in the future, if we not be careful, we can be same dependent on countries who has these rare minerals. So hydrogen probably is, in my opinion, is quite good solution for railway lines what cannot be electrified, because it's have a more wider operation distance, up to 1,000 kilometers. It's quite quickly can be refilled by hydrogen. And but this also, this moment, because it's not so many trains produced with this technology, it's approximately these trains more expensive by 50% than DMUs. But by 2050, around 30% of existing DMUs in Europe can be replaced by hydrogen trains. So in this example of Alston, Canadian hydrogen-powered regional trains that went in operation in 2018 with maximum speed to 140 kilometers per hour. But saying about a battery in hydrogen trains, it's we speak about passenger trains. Regarding the freight trains, it's not so simple, because these hydrogen and battery trains not so powerful for freight trains. Yes, it will be. It needed more researchers and more develop these technologies to be able to use to operate freight trains.
Inara,
So
do about another 5 minutes.
Yes, I will try.
Okay.
Yes, thank you. So here in these slides, you can see the train specification of Alston Coradia train, hydrogen train specification. It's approximately 150 seats and 150 more people can stand. So now in these slides, you can see countries recently involved in fuel cell hydrogen train experience, and one of them Latvia, because if you remember one of the slides, I said they have 100% diesel powered locomotives. No, and of course, more countries around the world. So Europe market potential for fuel cell hydrogen multiple units will increase from 30 in 10 times just in 10 years. They have big market. So now what we are doing in UK and what UK plans to accelerate the decarbonization of transport. In recent 2 years, in last 2 years, the 5 papers, I choose 5 papers most interesting for me, what were published, and on these topics. One of because railway network in UK, it's near 16,000 kilometers of track. We have over 30,000 bridges, tunnel, and viaducts, and we have over 2,500 railway stations. So the Network Rail Decarbonization Program include themes network rail road fleet, because network rail have not only trains but have road fleet also, which need to be decarbonized. And it includes theme as renewable energy generation and storage, manage station energy use, improving general energy efficiency, electricity connections to the network, considering carbon investment and sustainability culture. This document identifies the optimum development of battery, electrification, and hydrogen to the an electrified UK rail network. So, and the network rail traction decarbonization network strategy identified the work that need to do to achieve zero carbon by 2050. And it's said which how much railway line need to be electrified, how much need to put hydrogen trains, battery on. So some of 30 kilometers of single track not been technology choose up to now. So another paper is rail delivery group sustainability station, the best practice guide, April 2021. This document consider how stations can play their part in the government's commitment to deliver net zero emissions by 2050. Need to remember that railway network include not only railway track but stations also. So in one of examples, I can show you at Blackfriars railway station in London. They have on roof 4,400 solar panels, and it will reduce by 511 tons CO2 emissions annually. So next plan, and it's most, I would say, most important, most crucial for railway in the UK is William Shape's plan for railway. It is implies that will be created new public body, Great British Railways, which will new organization. It will manage a station and railway network, and franchising will be replaced by new passenger service contracts. So this moment, the rail sectors too often loses sight of its customer, both passenger and freight. It's missing opportunity to meet the needs of the commuters it serves. It is fragmented, and accountability are not always clear. The sector has lack of clear strategic directions. It needs to become more productive and tackle long-term costs. It struggles to innovate and adapt. And it will be Great British Railways will develop a 30-year strategy and 5-year business plan, manage a railway budget, be responsible for safe and efficient operation, own stations and infrastructure, plan access in the public interest, support the rail freight market and cross-regional services. And so it will structure what we have now. We have Secretary of State and Manager Infrastructure Funds and Franchising Authority. And money goes around, and from train operators to network rail, then Department of Transport, that go again to train operator companies. But in the future, we will have only Secretary of State would be managing Great British Railways, and a flow of money will be more easy. It will be from Department of Transport and another public funders and passenger fares go to Great British Railways. Great British Railways pay fees for passenger service operators. So yes, and this by comprehensive environment plan for the railway network will be published this year. So yeah, this is kind of expand. And yes, the UK Department for Transport published paper Decarbonize Transport for a better greener Britain. And by 2030, freight operating companies will use more electric and low carbon traction, will will be investing in high-speed railway and extra capacity. By 2040, all diesel-only trains to be removed from the network. And by 2050, the railway network will be carbon net zero. So, and the last paper what I want to mention, it's Rail Environment Policy Statement of Track for the Clean Green Railway Development of Transport, published in July 2021. And again, it said about reduction, reach zero emission by 2050, by 2040 remove all diesel-only trains, and reach electrification, improve quality of air, and more carefully be with biodiversity, reduce also railway network cars be zero emission by 2027. Yes, and yes, important, of course, have zero waste from railways by 2025. And so, conclusion, decarbonization in the railway industry can be achieved in many ways. It is electrification. It is better managing end-of-life rolling stock. It replacement current materials by composite materials, and improve the planning of strategic rail track and railway stock maintenance. So it's my references. It's please, thank you very much for your attention. And if you have any questions, please.
Okay, Inara, thank you very much.
Well, I'm sorry, I was a little bit late.
It's all right. We have 5 minutes left and maybe a little more. Anybody have any questions for Inara? She covered quite a broad spectrum there, and it probably had various interests from people on those areas. So please, any questions you might have for her.
May I ask a question?
Certainly, Bruce.
Can you see me? Do you want to see me?
We see you now.
Can you hear me?
Yes.
So, Mike, do you hear me?
Yeah.
Yes.
Yeah.
I guess you don't.
Yeah, no, we do.
Oh, you do?
Yeah. Now go ahead, Bruce.
Okay. So thank you very much, Inara. On behalf of the Rail Interest Group, because I happen to be chair of the Rail Interest Group. This is a very, very important topic. I guess my question is, the papers that you talked about at the end are very upbeat, going to get rid of all diesel locomotives in 18 years, and in 28 years the railway will be carbon neutral. Do you think that we've actually got plans in place that can achieve that? And from the tone in my voice, I don't. But I'm prepared to be told I'm wrong.
Yes, I would like to think, well, we will achieve, but this moment, I'm not, well, I'm not sure, because lots of questions are left outside what is said in these papers, and how we can achieve on it's difficult to plan with what change with changes involved have, because few years ago we said we needed to reduce nuclear power, but now last week in government and said we needed to build more electrical nuclear power station, because yes, it's nice plan, but how we achieve, well, it's questionable. Yes.
Okay. Any follow on, Bruce? Oops.
So
Bruce, are you
except
there?
trying to find the unmute button. I mean, it's a different question, and I don't want to hog the question. I've got quite a few, so I'm just going if no one else wants to. But there's a really important way of reducing the carbon emissions from the railways, which hasn't been mentioned, despite the fact that COVID has caused us to do it, and that's to have fewer passengers and fewer train services. What do you think?
Well, yes, my parents work on the railway. I grow up on the railway carriages. I want to think. I like railways, and I think it is. It will. We will increase number of passengers, but not only COVID affect what changes we have in society, but general how we live, how we work. I think to be practical, and maybe a little on concern side, but I think number of passengers, what was put in the example for high speed 2, we never will reach. A number of passengers and people who travel will be reduced, because the people will travel for leisure, but will be less different business travel, less conferences, less needs to travel. And I think what we have pre-COVID number of passengers, I don't think so we will reach these numbers. We not needed, in my opinion. If we wanted to reduce CO2 emission, we not needed to look how we encourage people of travel. No, we needed to look how we can reduce needs for travel for people. This is my opinion about, about this travel.
Thank you.
Yeah, thank you for question.
Anybody else? We have a few minutes, well, a few minutes left, or it's actually, I already have 2030 UK time, but we'll take one more question.
Is it me again then, Mike?
Yeah, might be Bruce.
Yes, why not? Why not?
One more.
Yes, of course.
It's not a question. It's really, I suppose, a remark to everyone on the call, which is to say what I think you've shown us in Inara.
Yeah.
Is that the future of the rail industry depends upon how successful we are at decarbonizing it. If we are really successful, then we become an important part of the solution to allowing people to travel without emitting carbon dioxide. And that means the railways will thrive. And if not, they will wither. So, I mean, saving the planet is such a big thing that it's hard to focus on it. But, you know, guys, if we don't get the carbon out of the railways, we're not going to have jobs. Am I being too harsh?
No, I think no. And I think another thing, we not talked so much about this, but now science go forward and develop so quickly. In next 5, no, maybe 10 years, we can have different mass transportation mode. We don't know now and don't talk about this, but I think railway can probably no, not the transport of the future.
Could
Okay.
you say that last sentence again, please?
Okay.
Inara?
I spoke with some professionals on what people think. In next probably 10 years, we can have different mass transportation mode, different from railways, different from road transport, something absolutely different. And this new transportation mode will be more efficient, more have higher speed. Because of this, probably we built now railways for 100 years, but I don't think so. After 100 years, we will still have these railways, because look what happens in previous 100 years, how big a jump, technological jump we have. Because when we this moment invest in big infrastructures, I always ask myself, do we need this built now? Do we need embedded this CO2 emission now? Maybe better to do something to reduce need for travel than build new roads or new railways.
That's a fascinating bombshell on which to.
I'm sorry.
So, Mike, if you're after you've wrapped up, the RIG committee ought to have a give some thought to what it's going to do after the end of the railways.
Moving to the new mode. Well, Inara, well, maybe you want to come back and talk about that.
Yes, why not? If you invited me, with all my pleasure.
Okay, I want to thank everybody for attending, and we finally had Dr. Inara Watson, and it was a great presentation. So it will be on the TWG website with all the other previous webinars for everybody to enjoy over and over. All they have to do is go to the link and click. Anyway, I want to thank everybody, and thank you, Inara. It was a great presentation.
Thank you. Thank you. Thank you.
Thank you very much.
Thank you for your kind attention. Thank you. Bye.
Okay,
Thank
I'll
you,
stop.
Laura.
There you go. I'll stop the recording.